For years, AI assistance meant predicting the next 10 characters at your cursor. Today, it means orchestrating operations across an entire connected codebase. When early autocomplete tools launched in 2021, they operated with intense myopia. They evaluated the few lines of code immediately preceding your cursor, but they were blind to the broader architecture. That limitation is gone. The modern system is an active partner, equipped with comprehensive workspace awareness, processing hundreds of interconnected files simultaneously. Realizing these productivity gains requires a change in workflow. Developers must shift from passively accepting inline suggestions to actively directing the AI via systemic prompts. The efficiencies reported in industry studies are directly tied to how AI processes codebase context. The engine powering this modern IDE integration relies on specialized GPT-4o class models, fine-tuned specifically for deep code reasoning. The defining structural upgrade is a massive 128 kilobyte token context window. This capacity allows the model to load and evaluate your entire project structures simultaneously. To fill that window, the system relies on Retrieval Augmented Generation, or RAG. The RAG pipeline dynamically scans your repository. It extracts relevant logic and internal functions, injecting them directly into the prompt payload before the LLM ever sees the request. This integration gives the LLM the specific, local data needed to function as a domain expert. The most foundational layer of this intelligence stack is the implicit context processing that happens every time you type. As you work, the system constantly evaluates the specific semantic meaning of your active file. Simultaneously, a background parsing mechanism reads and analyzes all the adjacent tabs you have open in your editor. It maps out your local project imports, scans your package dependencies, and evaluates framework-specific routing rules. Because it gathers this implicit context, the AI injects highly specific, framework-aware code, like perfectly structured React state hooks or Spring Boot annotations, rather than outputting generic algorithms. It executes this data gathering under severe latency constraints. This massive local evaluation occurs in milliseconds, providing inline completions 50% faster than previous iterations. The model also scans for the structural patterns and naming conventions you've already defined within that local scope, ensuring the new code matches your existing style. Modern inline suggestions do not guess syntax. They actively resolve local dependencies on the fly. The real power emerges when you move from implicit autocomplete to explicit conversational prompting through the chat interface. Mechanically, this shifts the interaction. Instead of waiting for the editor to predict your next structural move, you initiate active logic queries against your codebase. To make this process perfectly efficient, the system uses /commands. These are targeted execution directives that bypass conversational pleasantries and force direct computational action. Typing /explain instantly deciphers dense, undocumented legacy logic. You can highlight a complex block of regex, and the system breaks down its exact function in plain English. The /fix command allows you to feed raw error traces directly into the interface, so the system can identify the root cause of runtime failures. If you input a stack trace showing an undefined is not a function error inside a map method, the AI automatically generates the missing array validation logic and applies the correction. Conversational abstraction creates an environment where the IDE functions as an active, AI-assisted debugger. The highest layer of the intelligence stack introduces Workspace Commands. These directives execute operations across your entire multi-root project structure. While standard chat relies heavily on the files you have open, Workspace Commands possess full project awareness. They understand the entire repository architecture. The primary engine for system-wide structural changes is the /edit command. You can use this to convert legacy architectures into modern frameworks. The command simultaneously propagates updates to state management files, component interfaces, and module exports. It guarantees all references align so the build doesn't break. To target algorithmic bottlenecks, you deploy the /optimize command. This specific operation rewrites nested loops into efficient lookup structures, which reduces time complexity from O(n)² down to highly efficient O(n). For building complex typed infrastructure from scratch, the system relies on the /generate command. By ingesting an open API specification, Slash generates scaffolds of fully typed TypeScript SDK, complete with proper error handling and strict typing. Once the components are built, the Slash tests command automatically constructs comprehensive end-to-end playwright test coverage, mapping out both happy paths and edge cases. Finally, the Slash security command operates as an active scanner. It isolates vulnerabilities like string concatenated SQL injections and suggests precise parameterized query replacements. Mastering Workspace Commands elevates the developer's role. You spend less time writing individual syntax and more time designing application architecture. Integrating deep reasoning into the IDE immediately raises a critical enterprise objection: the risk of exposing proprietary intellectual property. To mitigate this, a strict privacy boundary surrounds the local retrieval network. Data leaves via an encrypted tunnel, undergoes stateless processing, and returns safely to the client. This architecture provides a robust enterprise control schema. Administrators dictate the specific model selections and enforce strict SOC 2 compliance protocols. The core security guarantee is absolute. Private organizational code is never retained, and it is never used to train public foundational models. This stateless processing architecture allows teams to deploy enterprise-grade AI without compromising a single line of proprietary code. This chart summarizes the productivity impact of these architectural mechanics, showing reduced development time across core tasks. Based on Microsoft studies, developers report a 70 to 85% reduction in writing boilerplate and a 60 to 75% reduction in debugging. There's also a clear downstream impact on system stability. Organizations utilizing AI-assisted test coverage and code review see a 25 to 40% drop in bugs reaching production. Extracting these results requires developers to adopt a new practice: context engineering. You have to proactively manage what the RAG system sees. This means intentionally opening relevant architectural tabs and writing highly descriptive, precise function names to guide the context parser. It requires strategic command chaining, starting broad with /generate to construct a module, refining the output with /optimize for strict error handling, and locking it down with /tests for exact coverage. The modern IDE is an active collaboration space. Building complex systems now depends on the developer's ability to engineer the right context for the AI.